Hey Valley Metal, welcome to tonight's video on decomposing polygons. Sounds gruesome and gory like a decomposing body, but it's really much simpler than that. A very easy target tonight. But let's start with the trivia question. I know you've heard this before, but let's see if you can learn something new about it tonight. What fraction of the Earth's surface is covered by water? I'll give you an interesting fact about that when we return. But first, our target tonight officially, lesson 10.8a, I can calculate the sum of the interior angles of a polygon by breaking it into triangles. Let's do this thing. Alright. What the heck is the measure of x? Angle x right here. Well, how are you supposed to figure that out? Alright, well, there are ways to figure it out. First of all, we're given 4 angles of the 5. And you need to figure out what that 5th angle is. We have to know what the total number of angles is before you can do that, right? All right, so what you do is you take any point on a normal polygon or a simple polygon, and from that point you make triangles. You connect to other vertices. Like I can't connect this point to this point and make a triangle because there's no area there. But I can connect this vertice to that vertice and make a triangle here. And I can take and make a second triangle by connecting this vertice to this one. Notice I stay off one vertice. I end up then with 3 triangles. This triangle, triangle 2, and triangle 3. All you have to do to find the interior angles then is take 3, the number of triangles, times 180 degrees, because that's how many angles that's the number of degrees in a triangle, and that's what you get. 3 times 180 equals 540 degrees. That's the sum of the interior angles. So to find angle x, you just simply subtract everything else. So you have a total of 540, be the total sum of all of these angles. And if I subtract 90 and 90, these are those 2 down here, and I subtract 135 and 135, the 2 angles up here, I end up with 90 degrees. So, the answer to our question is angle x is equal to 90 degrees. And you can kind of see it if you look at it this way, that it's a square angle. But instead of guessing, now you know how to do it. All right, I'm going to take you through several examples of this tonight. Very simple. It's called decomposing polygons into triangles, but I just call it breaking them into triangles. So the word of the day is interior angles, which is the measure of this angle on the inside, not the measure of the angle on the outside. That's why I pointed the arrow to the outside angle. This forms an angle on the outside too. I put a red bar through that. We're looking at the total number, the sum of this angle plus this angle plus this angle plus this angle plus this angle. In a pentagon, there would be 5 angles. All right, let's take a look at a couple simple examples. Here is this quadrilateral here. We need to find the sum of the interior angles. So I'm going to I picked out one of my vertices, pick it, and from that I'll connect it to any other vertices. I can only do that one time in order to make triangles, and so I'd have 180 total degrees in this little section and 180 in this section. That would give me a total of 2 triangles times the 180 degrees, giving me 360 degrees. And we know that too, but I just wanted to prove it to you. Any quadrilateral has 360 degrees. That's the sum of the interior angles. If you added up all the angles together in the inside, that's what it would be. All right, here's a different looking polygon. And again, I started with one point down here, called it point 0, and I went to this point. It would be 1, 2, whoops, I can't do that one, can I? Because it doesn't make a triangle. So here, 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 here. All right. Now, I've got 1 triangle, 2 triangles, 3, 4, 5. So for this polygon here, and I believe it has 7 sides, 1, 2, 3, 4, 5, 6, 7. So for this 7-sided polygon, I take the 5 triangles I made times 180 gives me 900 degrees. That's the sum of the interior angles. That's our target for tonight. It's really quite simple. Let's try a couple of examples together, and I'll cut you loose on your own. Find the sum of the interior angles of this polygon below. All right, I've made a checklist for you. Step 1, choose one vertex. Let's pick this guy down in the corner. I like that one. Step 2, connect that point to other vertices to create triangles. All right, so I'll grab a line here. And let's see, can I, oops, sorry about that. That doesn't make a triangle, but this makes a triangle. There's one triangle. Let's grab another line. Let's see. I can make a second triangle by connecting that vertice. Let's grab this guy. And I can make another triangle there, but I can't make one down here. That would be just tracing that line. So I've made a total of 1, 2, 3, 4 triangles. All right, now let's get my calculator out. So I have a total of 4 triangles. And I'm going to multiply that by step 4, 360 degrees, 4 times 180 degrees. I'm sorry, I said that wrong. Equals 720. Should be 180 degrees. Very good. 720 degrees. That's the sum of the interior angles, just like that. Let's try this next example, and I got to correct this real quickly. I have to do that several times because I cloned this line. All right, find the sum of the interior angles. Once again, just let's pick this guy here. You want to do something different? We'll pick this one here. Pick this angle here, and then we'll get a line. Just click on it, and let's see. I can't go there. That doesn't make a triangle. This makes a triangle. Pick any point and just keep coming back to that point. This makes a triangle. Grab another one. I can connect this vertex to make a triangle. Sorry, I could make it a little neater there, but you're getting the idea. I can connect this one, but this one here, if I connect it, it's just not going to make a triangle. So let's see what I ended up with here. I got 1, 2, 3, 4, 5. So I've chosen a vertex, I connected the points to create other triangles. I counted them, I have 1, 2, 3, 4, and I have 5 triangles. If I multiply 5 times 180 on my calculator, I would get a total of 900 degrees. So the sum of this angle plus 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 this angle, all the interior angles equals 900 degrees. All right, you ready to try one? All right, you're on your own. Go for it. Okay, let's see how you did. If I take and put this little doodad down here and grab a line, I can make a triangle out of this one. I can make a second triangle here connecting this vertice. Grab another one. Let's see, I can create a triangle here. Connecting that vertice. Connect these 2 vertices. And I think I can do one more. Here we go. Connect these 2 vertices. So I picked one vertex, connected it to the rest of the vertices, and I got 1, 2, 3, 4, 5, 6. And once again, I have to change my little number down here. Multiply those 6 triangles by 180 degrees. So I had 6 triangles. Let's clear this out. 6 times the 180 degrees that are in each of those triangles, and I get 1080 degrees. That's the sum of the interior angles. All right. Sound good? Pretty simple target, right? Did you notice anything? Look at this. 3, 180. 4, 360. 5, 540. 6, 720. 8, 900. The sum of the interior angles is equal to the number of the sides minus 2 times 180. So look at 3, take away 2 is 1, times 180 is 180. 4 minus 2 is 2, times 180 is 360. 5 minus 2 is 3, times 180. So you always subtract the number of sides and multiply it times 180. Take a look at the octagon we just did. 8 sides minus 2 gives us 6, times 180 is 1080 degrees. Neat little shortcut you can try. All right, yeah, but there's always a yeah, but. And this could be it should be the last yeah, but of the year. Find the sums of the interior angles of the polygon below. This here is a concave polygon. Notice how, it looks like the state of Minnesota, but notice how this side is pushed in? Concave means goes in like a cave. The simple method I showed you will not work for this one right here. You have to make sure that all of the sides are convex or pushed out. Simple and convex polygons. The simple method I gave you works for. All right, here's your ticket to the show. Find the sum of the interior angles. Let me help you with this. 1, 2, 3, 4, 5, 6, 7, 8, total of 9 sides. And you can go ahead with that. All right, I'll stop for a minute in case you want to pause. All right. Trivia question. What fraction of the Earth's surface is covered by water? I think most people know that it's 2/3, but here's a quirky fact. Almost 2/3 of the Earth's surface is covered by water. If the Earth were flat, there were no mountains or valleys, water would cover everything in a layer 2 miles deep. That's a lot of H2O, my friend. Or in the way the water boy would say it, that's some serious H2O. Sorry. Take it easy. Have a nice night. Thanks for watching.